Hello, and welcome to MainView AutoOperator MVAO 201 Advanced Facilities. MVAO 201 is the fourth in an 8-part series of courses covering MainView AutoOperator. In this session, we'll be discussing AutoOperator alerts. So when you're building a rule, you will see on many of the definitions, you'll have these alert action displays. And I want to go through these and explain what the most important fields are. So when we see this display, here we have the option to generate an alert for a rule. And the first thing we're going to do is specify the function that we want to take. So do we want to add the alert? Do we want to delete the alert? Or do we want to delete the entire alert queue? And then we need to specify a key for the alert. And the key is how AutoOperator keeps the alert separate from all the others. It makes it distinct. Typically what you'll do for the key is you'll use a message ID and then the object that's being affected. So if it were for a CICS transaction, you would capture the message ID and then you would append the CICS transaction to that message ID so that the alert is unique for that transaction and that type of condition. And that usually works out pretty well. You'll also want to specify a queue to which to put the alert, and that's just a way of organizing your alerts. We specify our priority, which would be something like critical, major, info, so on and so forth. You can specify the color optionally, but by default it'll come to the OSI standard. So for instance, if it's critical alert, then the color will be red. A P command allows you to specify an embedded transfer command in your alert, so you can go to any place you would like in MainView. Down here under exec, we can specify an exec we wish to run along with a whole bunch of parameters, and I'll show you what that looks like in a minute. And then down at the bottom, we have a publish option. And what this does is allows us to send the alert off the platform to another solution such as BMC Impact Manager. If we place a question mark in the exec field, what we're going to get is a panel like this. And you can see AutoOperator presents us with a lot more real estate to invoke the exec and pass parameter strings. Down at the bottom, we can optionally specify the priority for the exec. So by default, it's normal. That's typically going to be what you want. We can leave that as is. And then at the bottom, we have a delay field that says how long I want to wait before I actually start this exec. So just to revisit some of the fields we've seen in the alert panels, the text is the actual message text of the alert. IMF text is the actual message text that came in to generate the rule. And oftentimes you will repeat that in the text of the alert itself. The queue and the key allow you to manage your alerts by either queues, which are containers to hold your alerts, or keys that allow you to manipulate them in the future. Maybe you want to delete them after certain events occur. Priority allows you to assign a priority or color coding to the alerts so you get the critical ones up at the top. P command allows you to create a product transfer to any of the other MainView solutions. And then you can create your own help panels, which are a good way of documenting your standard operating procedures behind the exceptions, so the operators will have immediate access to that information. When you begin working with alerts, it's important to have well-formed standards for the names of your queues as well as your alert keys themselves. The alert keys need to be unique within a queue name, and if you happen to generate an alert that has the same key as a previous alert, it will overlay the previous alert. Now, in some instances, that's going to be desirable, but you need to be careful that it only occurs when you want it to. Okay, now the alert keys can be a constant, a variable, or a combination of the two, 24 characters maximum. And typically what you will do for your alert keys is use the message ID and then the object that it affects, such as a system or a transaction or a database, what have you. So let's look at an example here. If I have a queue MVS, alert queue called MVS, and then I have an alert with a key of 123, it'll generate that alert. If I write another alert to queue MVS and it has a key of 456, it'll also generate a new alert. And then if I have a third alert with a queue of MVS and it also has a key of 123, it's going to update the previous alert with a key of 123 and put the new data into it. Let's consider an example of using an alert key. So in this instance, we want to trap a message where an IMS transaction ended. And you can see here that's the DFS 554A message. So what we're going to do with this one is we're going to trap the message ID, which is word 1, and then we're going to append to it word 3, which is the transaction name, ABCD. So if I set my key to ampersand word 1 underscore ampersand word 3, that will result in a key called DFS 554A underscore ABCD. And that's a well-formed standard that will generally provide you with the uniqueness you're looking for. Now, another way to create unique keys is use the IMF rule ID and the IMF rule fired. The problem with these, though, is it's difficult to identify what the alert key was if you want some subsequent automation to clean that out and delete it. So the message ID and the object name typically work the best if those values are available to you. The next alert actions display tells AutoOperator how to handle the alert once it's been generated. The auto delete field will say if the highlighted message on the console gets DOM'd, I want you to go ahead and delete the alert with that. The retain option says whether you want AutoOperator to retain the alerts over IPLs or restarts of the AO subsystem. The escalate direction says, do you want to escalate up in severity or down in severity? And then the interval values indicate how many minutes we wait till we go to the next level of escalation. Okay. At the end, you can say whether you want to keep or delete that alert. And then at the bottom, you can see there's a final action where we can specify to invoke an exec or issue a number of different types of commands. So if I put a question mark in that bottom field for the commands, here's a list of the values that are available to me. I can run execs, I can issue JES or MVS commands, I can issue BBI commands to the journal, IMS commands, CICS commands, MQ commands, NetView commands, and if you're using Tom, you can use Tom commands. So quite a variety of different things we can run as our final action on our alert. And again, revisiting what's on the panel, auto delete deletes the original alert when the WTO is DOM'd. The retain option allows you to retain your alerts across IPLs and cold starts of the BBISS. The escalate direction says where you want the priority to go up or down, and then we specify intervals between the changes in the priority. And the final action specifies what you want to do when the alert has reached its final escalation point. Now, important to note, you cannot do both the retain and the escalate functions for your alerts. So you have to either decide whether you need to retain it across IPLs or cold starts, or whether you want to escalate the priority. A couple things to point out when you're generating alerts. It's very important to keep the creation of alerts to a minimum. And the reason you want to do that is when you have a screen full of critical alerts, the operators don't know where to begin. When they find out that they can ignore half of them, they tend to miss things that are important. So it's really critical that you keep your alerts to a minimum only when some type of action or notification is truly required. It's also important to point out that your alerts go away when the BBISS, the MainView address space for AutoOperator, gets recycled. And the way around that is to use the retain option in your alert specification. Within MainView AutoOperator, we display the alerts in 3 different formats. The first is the summary graphic display, which displays bars of the various severities of alerts broken out by queues. From there, we can do a PF5 or expand, or we can go to the alert detail display, and we'll see a list of all the alerts with their message text and as well as their origins and some other things that we can view. Now, from within the detail display, we can use the PF4 key to transfer to a MainView display. We can do a PF5 to display any embedded help that's been put into the alert. And then if we do a PF6, we can get all the detailed information about how the alert is defined. We also have a display, the ALS display, which shows us the number of alerts by queue and status, severity, in a tabular format. So if I go ahead and I want to see the detail of an alert, this is how it will be displayed. And it provides a nice summary display of all the definitions in a single screen, rather than having to see it go through all the rules displays. And if you go to the next screen, you'll see the escalation information for the alert. We can also look at the alert details in the Windows mode of MainView, and this is how it'll look. You get more real estate, so we can get all the data onto a single display, which is nice, but it's essentially the same data you would see in the typical AutoOperator rules processor. Now, most companies like to consolidate their alerts to one display because you just don't have the screens to support a large environment anymore. Historically, this is done by sending things off the platform to maybe a Windows box or something like that, and you'd have a solution there, maybe something called the LAN or BMC Event Manager, what have you. That worked out okay, but we have a better way to do it now, and that's using the MainView Alerts display. It's a part of the MainView Alerts application that runs in the MainView infrastructure. And what we can do is we can look at that display and see all of the alerts throughout the environment. In addition to the MainView AutoOperator alerts, we can see alarms from MainView as well as some monitor exceptions that can be generated from the OLTP solutions. So this is how the data is displayed in the alerts application. You can see up at the top, looks very similar to what we saw for AutoOperator. Again, the biggest difference here is the data can come in from multiple sources, and we get a consolidated display for your entire environment. That concludes this session on AutoOperator alerts. Thank you and have a good day.